بسم الله والحمد لله والصلاة والسلام على محمد رسول الله وعلى آله وصحبه ومن والاه. I will talk about Room database for Kotlin Multiplatform. Room database is a great option to use for saving data locally on the device, and I will demonstrate basic CRUD operations in a simple to-do app. CRUD stands for Create, Read, Update, and Delete. Room database was originally developed for Android, and it's an abstraction layer over SQLite database. Room database for Kotlin Multiplatform is a great option because it makes it easier for us to manage and use SQLite database. It also provides compile time verification of the SQLite queries, which makes it easier for us to debug and fix the code. In this video, I will discuss Room for Kotlin 2.1.0. If your Kotlin version is less than that, this setup may not work. You need to check the documentation for the compatible KSP version. I will post the link in the description. The app will have a single UI made with Compose Multiplatform and Material 3 library. The UI will consist of a single screen which will contain a bottom app bar, a floating action button to add our to-do items, alert dialogues for the insert and update operations, a scrollable column, a lazy column, to display the list of to-dos, and each to-do item will have a to-do title, a delete, and an edit button. We need to download our project files. To do that, we go to kmp.jetbrains.com. We select a name for the project and the project ID. We select the platforms we want to work with and download the project. We open our project in Android Studio, switch to the project view. Let's start by adding our dependencies to the project. We need to add Koin dependency injection libraries and Room database libraries to our project. To do that, we open the libraries file in the Gradle folder. In the versions section, we add our Koin dependency injection framework version. I have a video explaining how to add Koin dependencies and how Koin works in a Kotlin Multiplatform project. If you're interested in it, I will leave the link in the description. We add the Room database version, the KSP, and the SQLite database version. In the libraries section, we have our Koin libraries, and we have our Room database libraries, the Room runtime, the Room compiler, and the SQLite bundled. In the plugins section, we add the Room plugin and the KSP plugin. We switch to the build.gradle file. In the plugins block, we add the Room plugin and we add the KSP plugin. In the Kotlin block, in the source sets, we add the Koin for Android and Koin for the multi-platform. We add our Room database and the SQLite bundled libraries. In the project level, there is a dependencies block. We add our target platforms, and we use the add keyword to add our Room compiler for Android, desktop, and iOS. We need to set up the schema directory, and to do that, outside of the dependencies in the project level, we use the Room plugin to set our schema directory. You can change this directory if you want. This puts the database folder in the project directory. I will use the Material 3 library for the UI in this project. To change to Material 3 library, we go to the common main dependencies block in the source set and change the Compose material to Material 3, and we sync the project files. Since we switched to the Material3 library, let's do some cleanup on the code. We go to the common main. In the projects directory, we go to the app file. We need to correct the imports. For the material theme, we just import the correct Material3 and we delete the old libraries. Let's delete the code in the Material3 block. We don't need it. Now we will be ready to use this app composable when we need to create our UI. Let's go ahead and delete the greeting and platform KT because we don't need them as well. This is part of the example. We select those and delete. We need to delete those files in the desktop main, in the iOS, and in the Android. We need to delete the Android file as well, the platform.android. Now we should be good to go in writing our own code. I will follow the app architecture recommended by Android developer website. I will post the link in the description. This architecture is not mandatory, simply you follow the architecture policy of the project you're working on. The app will have a data package for our data sources, DI for dependency injection, and I will use Koin dependency injection framework. I have a video on my channel, and I will post the link in the description. Domain for our use cases, and UI package for our UI files. To create the database, we need to define the data model or class of the to-do item. We create a model package in the data package, and we create a to-do item data class in it. In order to use the data class in Room database, we need to annotate the class with the entity keyword. The data class will represent a column in the database. We will need to create a primary key for the column. We create an ID variable and set it to be an auto-generated primary key. We create another variable for the to-do title. The other thing we need to create is the data access object, or the DAO interface. The DAO offers an abstraction access to the database at compile time. Room will automatically generate the implementation of the DAO that we define. In the data package, we create a DAO package. In the DAO package, we create the DAO interface. We annotate the DAO interface with the DAO keyword. In the DAO interface, we have room annotation keywords that we use to interact with the database. We use the insert annotation to create insert function to add a new to-do item. The update annotation to update an existing to-do. The delete to delete a to-do. To get all the to-dos in the database, we use the query annotation to write SQLite query that will return all the to-dos in the database as a list inside a Kotlin flow. Now we're ready to create the database class. In the data package, we create a new package and we call it localDB for database. We create a database class, call it RoomDB, and change it to an abstract class. The RoomDB class will inherit from the Room database class. In the Room database class, we add an abstract function that will return the DAO interface we created. We annotate the database class with the @database annotation. The database annotation will have some parameters: the entities parameter for data models, the version parameter for the database version, which is important when we want to update or change the database, and export schema parameter if we want to export the database schema. We must add constructed by annotation and add the database constructor class to the annotation parameter. We create the expect class for the database constructor. We don't create the actual implementation because the Room compiler will generate the actual implementation. Android Studio might issue a warning for the missing actual classes, so we suppress those warnings with no actual for expect annotation. Now we create a class to create the database. In the local DB package, create a new class and name it Create Database. The Create Database class will have a database builder as a private parameter. We need to create a builder for each platform. We will use Koin to inject the builder from each platform. In the Create Database class, we create a function, call it getDatabase, that will return the roomDB class that we created earlier. In the return statement, set the fallback migration option to destructive migration and drop all tables to true. We set the database driver to the bundled SQLite driver, set the query quarantine context to dispatchers.io. Finally, we built the database. Now we can move to creating the database builder. Let's create the database builder for Android. In the Android main directory, in the projects directory, I created the data, the local DB, and the DI packages. I tried to keep the project structure identical to the common main directory in all platforms. It makes it easier for me to find the files and trace the code. In the local DB package, we create the file, call it Android Database Builder. In the builder file, we create a function and we call it Android Database Builder. We add context to the function parameter. The function will return the room database builder. In the function's body, we create the database file by using the application context. We set our database name, then we return the builder and we pass the context and the database file to the builder. In order to get the database builder, we need to use Koin dependency injection. In the DI package, we create an Android database module file. In the file, we create Android database module. In the module body, we create the dependency injection singleton of the database builder. We create the application class in the projects directory in Android main and add the start Koin to it. We pass the Android database module to the start Koin function. And finally, don't forget to register the application class in the Android manifest file. Let's create the database builder for the desktop platform. In the desktop main directory, in the projects directory, I created the data, the local DB, and the DI packages, the same way I did for the Android platform. In the local DB package, we create the desktop database builder function and create the database file. We don't need to pass context here. The function will return the room database builder. In the DI package, we create the desktop database module and we create the database builder singleton. Finally, we pass the module to the start Koin function in the main.kt file. Let's create the database builder for the iOS platform. In the iOS main directory, in the projects directory, I created the data, the local DB, and the DI packages the same way I did for the previous platforms. In the local DB package, we create the iOS database builder function and return the room database builder. We don't need to pass context here, but we do need to create a function to create the database file and return the file path. In the DI package, we create the iOS database module. In the module, we create the database builder singleton. In the DI package, we create an init Koin file. In the init Koin file, we create an init Koin function to start the Koin application. We pass the module to the start Koin function in the init Koin file. And we pass the iOS database module to the start Koin function. We open Xcode and call the init Koin function in Xcode in the delegate class. We go back to Android Studio in the common main directory in the DI package. We create a shared Koin module. In the shared module, we create the database singleton using the create database class that we created. To get the builder parameter of the create database class, we use a Koin function called get. Get will automatically look up the implementation of the parameter from each platform and pass that implementation to the class. Then we call the getDatabase function from the create class to create the database. Last thing we need to do is to add the shared module to the start Koin function in the Android desktop and iOS platforms. Now that we finished setting up the database, we move to creating the repository. We go back to the common main directory. In the data package, we create the repository package. In the repository package, we create a to-do repository and inject the roomDB class in the parameter. In the to-do repository, we create a private variable for the dispatcher and set it to dispatchers.io. Now we can create the CRUD operations. We create an insert to-do function to create a new to-do in the database. We request a to-do in the parameter to pass to the database. We use withContext function to specify the dispatcher and the database variable to access the database DAO. We pass the new to-do to the insert function of the database DAO. We do the same for the update and delete operations. For the get function, we don't need to use the withContext function since it's not a suspend function. So we create a regular function that returns a flow of to-do lists. Last thing we need to do is to create the to-do repository singleton in the shared model. Now we're ready to create the use cases. Each operation will have a separate use case. In the common main, in the projects directory, we go to the domain package and we create our first use case. It will be the insert to-do use case. We inject the to-do repository into the use case parameter. We create the invoke function and we request a new to-do item in the parameter. In the function's body, we pass the new to-do to the insert function in the DAO using the to-do repository. We create the update to-do use case. We do the same thing for the update use case as we did for the insert use case, except we use the update to-do from the to-do repository. And for the delete to-do use case, we do the same thing. For the get all to-dos use case, we just return a flow of the to-dos list. When we finish creating all the use cases, we create the singletons of the use cases for the dependency injection in the shared module. Now we're ready to create the view model. In the common main directory, in the projects directory, we go to the UI package and we create a shared view model. We inject the use cases we created as private parameters. And in the view model body, we create the corresponding functions to interact with the use cases. We create the insert and the update functions as variables to make it easy for us to pass them as parameters into the composables. We use the view model scope to launch the suspend functions, and to get all the to-dos, we return a regular coroutine flow that we collect in the UI composable. When we finish creating the view model, we create a Koin singleton of the view model in the shared module using the viewModelOff function. Let's create the UI for the application. We'll keep the UI to a minimal. In the common main directory in the UI package, we create a composable and call it home screen. We will inject the view model into the composable using the Koin viewModel function. We need to create a Boolean variable and call it showAddDialog. We use the remember composable function to save the state across configuration changes. The second variable is going to be a Boolean variable as well, and we'll call it showUpdateDialog. The third variable is for the to-do item that we need to update. We need to pass the selected to-do item to the update dialog. We need to collect the list of to-dos from the database. To do that, we use collect as state with lifecycle, and we set the initial value to null. Let's create a scaffold. The scaffold will fill the entire screen, and we will add a bottom app bar to the scaffold. In the app bar, we will add a floating action button to add the new to-dos. Pressing the add button will set the show add dialog boolean to true. Inside the scaffold, we will create a lazy column to display the to-do items. We will use the item indexed function to display the to-dos because we want to use the index to display the position of the to-do in the list. We create a list item composable. The leading content of the list item will be the index. The index starts at 0, so we just add 1 to start it at 1. The headline content will be the to-do title. In the trailing content, we will create a row and 2 text buttons. The first button will be a button to delete the to-do item, and we will use the delete to-do function from the view model. The second button will be the edit to-do button. In the on-click of the edit to-do button, we will have 2 actions. The first is to set the selected to-do item. The second action is to set the show update dialog to true. Underneath the lazy column in the box, we add a conditional if statement to show the add to do dialog, and we add another if statement to show the update to do dialog. Let's create the add to do dialog composable in the UI package. We create onDismiss function parameter for the dialog's dismiss action, and we create onConfirm function parameter for the confirm button. The confirm parameter will require a to-do item. In the composable body, let's create a basic alert dialog. We will clip the dialog to give it round corners. We add the onDismiss function parameter to the onDismiss request parameter of the basic alert dialog. In the dialog body, we create an outlined text field. We need to create a text variable to store the text input from the user. We set the value of the text field to the text variable we created, and we set the new value of the text variable to the new value that is entered by the user. We create a text button to confirm the input and add the new to-do. In the on-click, we will check if the text variable is not empty. Then we will add the new to-do to the database and dismiss the alert dialog. Let's create the update to do dialog. Most of the update to do dialog will be similar to the add to do dialog. The main difference is that we will add the selected to do parameter. We set the text variable to be a mutable state of the to do item title. In the button's on-click action, we will check if the text variable is not empty. Then we will update the to-do title and dismiss the dialog. We go back to the home screen. We forgot to add the update to-do function to the update to-do dialog. Then we go to the app composable. In the material theme block, we add our home screen composable, and now we should be ready to run the application. We run the application on Android. We add a new to-do. We edit the to-do. And we delete it. We run the desktop application. We go to Gradle Task Executor and we type compose app run. We add a new to-do for the desktop. we edited and deleted. Next, we run the iOS application. Same thing, we add a new to-do for the iOS, edited and deleted. Thank you for watching until the end. Don't forget to subscribe and like the video. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.